This is Josh White with JW Math Tutoring. Today's video is going to cover Bluebook Digital SAT Practice Test 10, the Math section, Module 1. So let's go ahead and get started.
But life is a dream the calculus could never predict.
Just before I start going through these problems from Bluebook Practice Test 10, Math section, Module 1, please keep the following things in mind. First, if you like this video, of course, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, this video may run past the allotted 35 minutes that you have to complete this module, and that would be because for some of these problems, I'm going to show multiple methods to solve them, which could include 2, 3, 4 different ways. Okay. On an official test, of course, you wouldn't need to solve these problems in, multiple ways unless you wanted to solve it once and then go back and maybe use a second method just to check or confirm your answer. And third, if you haven't done so already, please do check out the videos for the same Practice Test 10 Math Module 2A, the easier of the 2-second modules, and same test, Practice Test 10 Module 2B, the harder of the 2-second modules, once those videos are posted. All right, so with that said, let's go ahead and get started with question number 1. Here you have a basic probability question, and the answer to this is just going to be letter C. It's 29 out of 100 because there are 100 beads you could choose from. There are 29 that are defective. Therefore, probably just selecting a defective bead, just 29 out of 100. We can move on to the next question. All right, number 2. Here we have a basic linear equation. And they just want to know what's the speed 5 seconds after it begins. So that means we're just plugging in 5 for t. So this is just 40 plus 3 times 5 is going to be our S value. And that's just going to be 40 plus 15, or in other words, 55. So the speed is 55 miles per hour. Correct answer is letter D. Next up, here you have an equation, and they don't want the value of x, but they want the value of 24x. So there's two ways you could approach this. Quickest way is to notice, if you just multiply both sides by 6, the left side will equal 24x. The right side will also equal 18, which is letter C, the correct answer. Now, alternate way to do this would be just to solve the equation for x, and you get x equals 3/4, and then take that number and multiply it by 24. So 4 goes into 24 6 times. 6 times 3 is 18. Of course, you could do all this work by hand, or you could also just go straight to Desmos. You could do 4x equals 3. Okay, what do I get here? 0.75. All right, let's export that. And let's just do 24 times that, and we get 18 right there. Okay, so that's just an alternate method that you could use to solve this as well. Next up, you have a scatter plot, and there's a line of best fit shown on this scatter plot. Which equation represents this? So for this, you can actually use process of elimination to solve to get the correct answer, without even needing to solve for the slope or the y-intercept, because notice this will have a positive slope, and its y-intercept right here, somewhere between 2 and 4, will also be positive. So which equation has a positive slope and a positive y-intercept? Well, A does, B does not, the y-intercept is negative, C does not, slope is negative, D, both are negative. So the correct answer is A, and you really don't need to do anything more than that. But if you wanted to, we could still go to Desmos, and we could do a regression. We could look for some nice point values to pick. Let's see what I chose here. I chose 3, 6, so I estimated like right around here to be the point 3, 6, which is on the line. And then I think I also chose 7, 10. Yeah, so like if you look right here, this point, halfway between 6 and 8, and right on the marker for 10. And then we can click this button. Our linear regression is already done. The equation, y equals x plus 3. Okay, obviously that's not the exact answer. The slope is the same, it's positive 1. The y-intercept is not the same, but that's fine. None of the other ones make sense because the y-intercept is negative or the slope is negative. So this is just an alternate method that you could use to get the answer as well. Next up, question number 5, just a basic percentages question. You're here just basically figuring out 244,000 is what percent out of 300,000. So you're just dividing the numbers. Notice all these zeros first cancel out, so you're really left with 234 over 300, and that is just going to come out to 78%. And of course, you would probably just go into Desmos because you don't really know, you most likely wouldn't know what 234 out of 300 is. And see right here, we get this, and of course, to convert it to a percent, we're going to multiply by 100. So correct answer again is just letter D. All right, next up, we have a table of values, and they want to know basically what's the equation of this line. So first, a couple things. Notice that the y-intercept point is right here. Okay, the y-intercept value is 18, therefore the b value is 18. So answer choice A and answer choice C are automatically eliminated. Then to get the slope, well, first of all, excuse me, if you notice as the x's increase here from 0 to 1 to 2, the y values actually go down. That means this line is going to have a negative slope because as you move to the right, it's going to go from 18, then down to, 18, down to 13, down to 8. So which of these two answers has a negative slope? Well, D is the only one. So again, by process of elimination, you can get the answer to this as D. You don't actually need to calculate the slope value. But if you want to, of course, I would recommend going to Desmos, typing in some of the points. You only need to type in 2, but whatever, I'll type in all 3. Click the linear regression button, and there's our equation right there. Y equals negative 5x plus 18. Correct answer is going to be letter D for this. All right, next up, question number 77. Here we have a free response question, but we're just evaluating a function here. So all I'm going to do is just take 2 and plug it in for x. And so when you do that, we get 6 plus 76. So that should be, why am I, oh, I wrote the wrong thing here. 71, not 76. 71, 71. There we go, 77, the correct answer that I have in my notes. So that's how you could do it by hand. Or, of course, you could just go to Desmos. You could just type in function and then just go f of 2 and get 77 that way. So if you think that's quicker and easier, perfectly acceptable way to solve it, but the correct answer for this one is 77. All right, next up, number 8, we have some expressions that we are equating here. So using rules of exponents, we're multiplying here, so we're going to add the exponents. So 4 plus 1 is going to be m to the 5th. So notice right off the bat, again, process of elimination tells us the answer has to be letter B. None of the other ones have the right exponent power for m. But just to continue, for the q's, it's going to be 4 plus 5, which is q to the 9th. For z, it's negative 1 plus 3, which is z squared. Okay, all that matches with letter B. However, an alternate way you could do this is you can go to Desmos. And what we can do is we can type in the original expression, basically the two things that are being multiplied. And then we're going to add sliders for each of the variables. Okay, so let's add some sliders, just move them to, they have to be positive. That's the only condition. So, okay, the number's starting to get pretty large there. So let me just, whatever, dial this back a little bit. Okay. And then you would just go through the answer choices, you type them all in, and you see which one gives you the exact same value as I have in the top line there. So I'm not going to bother going through all of them, but I'll just show you. This one gives you the exact same number, 1577.479707, so on. Okay. You type any of the other ones, any of their answer choices, the number is going to be different. Now, you don't just leave all these at 1. You move them to something other than 1, because if you leave them all at 1, then the answer will just be 1 and they would all work, okay? So you do need to make sure you move the sliders to a number other than 1, if you're going to use this method. Next up, question number 9. Here we have two similar triangles. So if you draw a picture with both of these triangles, okay, so here is A, let's see, B, and C. Okay, I labeled triangles like this. BC is 850. And we have X, Y, Z. Just make sure they're in the correct order. Yep, A to X, B to Y, C to Z. Okay. YZ is 60. So, what is the length of XY? All right, so all we're going to do is just set up a proportion with the corresponding sides. So I've got basically this, whatever, I'm just going to call X. That's what we're solving for. So I said, okay, X corresponds to 170, in this triangle to this triangle. Technically, the one on the left is much larger because, 850 is much larger than 60. And then 60 from the small corresponds to 850 from the large. So we just go ahead and we cross multiply this. 850x should be 10,200, and then divide by 850, and we should get 12, letter G, as the correct answer. And let's just go to Desmos and confirm that. You can actually just really type the whole equation in and then look for a vertical line. Yep, right there, the vertical line's at 12, so that just confirms that yes, that is the correct answer. Next up, question number 10. Here we have a proportion, xy equals 4, and then you have another proportion, 24x over ny equals 4. What does the value of n have to be? Okay, so basically what's happening here is xy is equal to 4. So if you look at this thing right here, if you kind of split this up and make it like this, then you can replace x over y with what it's equal to, which is 4. Now, here you can just cancel the 4's out, but if, whatever, that doesn't. So the easiest way I would say from here is you cancel the 4's out, you get 24 over n equals 1. You can see n is equal to 24, or you can just multiply by n on both sides and you get n equals 24, which is the correct answer. Or if that's not obvious, if that's not intuitive, then instead do it this way. Just multiply and get 96 over n equals 4, cross multiply, 4n equals 96, divide by 4, n equals 24. Okay? And that's how you can get your correct answer. Next up, question number 11. Here you have a basic linear equation, and this is just this is basically just interpreting this linear function, this equation. So the volume that is draining each second is just going to be equal to the slope of the line. This function W models how much volume of liquid it says there is in a container t seconds after it begins draining. So the slope is just the change in the volume per, 1 second, per 1 unit of time, because t is your x value, t is your input variable. So correct answer for this is just D. And again, it's because the slope of this right here is 4. And so that's how we get the answer. Nothing else to do for this problem. Let's look now at question number 12. Here you have a graph of a polynomial function, cubic function. For how many values of it does f of x equal 0? This question is asking how many x-intercepts does this function have? Well, there's one right here. looks like -1. There's one here at 4, and there is one here at 7. So there are 3 x-intercepts, i.e. there are 3 values of x for which f of x equals 0. Correct answer is letter C. Next up, number 13, we have an exponential function here. Okay, and if you're familiar with the basic setup of these, it's like a, and then this is like 1 plus or minus r, and then here's where you have your exponent. So this is a basic form of an exponential function. R is either your growth rate or your decay or decline rate, whatever you want to call it. And A, the number out in front of the parentheses, is always your initial amount or starting amount. So that's what the 3000 represents in this problem. 3000 represents the estimated initial population in 2008, i.e. when this population reduction, whatever program went into effect. So therefore, correct answer for this is just going to be letter D. Next up, we have question number 14. We have a quadratic function here. First, I'll show you how to do this by hand, and then I'll show you how to quickly and easily do it on Desmos. So, if you're going to do this by hand, we know that the x-coordinate of the vertex, which is where the minimum is going to be, you graph out a quadratic function, the vertex is going to be its minimum value since this one opens up. That is -b over 2a. So that's going to be the opposite of -14 over 2 times 1, or 14 divided by 2, which is 7. So the correct answer to this is just 7. Now, of course, if you go to Desmos, this will probably actually be quicker. We just graph the function. All right, where does it reach its minimum? Let's click on it right here, 7 comma -27, and they want the x value, so therefore that's why it is 7. Next up, question number 15. Here you have one square which has side lengths that are 166 times the length of another square. The area is k times, the area of the other one. What is the value of k? All right, so the shortest, quickest, easiest way to notice this is that the scale factor between these two squares is 166. The area factor, i.e. ratio of their areas, is just the scale factor squared. So you just take 166 and you square it, and you should get 27,556. Let's just confirm that in Desmos. Yep, and that's the correct answer. Now, if you didn't know that, that's fine. Then what you could do is you could do picking numbers where you say, okay, here's a square with side length 1. Then here's another square with side lengths of 166, where they're each, 166 times that. Okay, what are the areas of each? Well, area of this is 1. Area of this is 27,556. Area of square A, which is the larger one, is how many times the area of square B? Well, 27,556 is 27,556 times 1. So therefore, K is just going to equal, that number. So that's an alternate way you could think about this if you're, not familiar with scale factor and area factor and how they're related. Next up, question number 16. Here we have a system of equations, and they want to know what the value of B is. So this one's actually not very difficult to solve by hand, because if you just basically like subtract these, or really if you multiply bottom one by -1, so it flips all the signs, this cancels. You get 4b equals 100, and then you divide by 4, and you get b equals 25. So that is the correct answer. But of course, it might be quicker just to go to Desmos and type both things out. Keep in mind, in Desmos, you are going to have to type x and y, not a and b. So you got to replace them, x and y with a and b. So let's zoom out here. Here's the intersect okay, you got to be careful. They're intersecting just right to the left of the y-intercept, which are also showing us the clickable points. So b here corresponds to y. Therefore, it just confirms the correct answer is 25. Next up, question number 17. What is the y-intercept on the graph of this function? So first, I'll actually show you because I think it's quicker in this instance. Just graph the function out. Where is its y-intercept? Well, it looks like it's at 0, 14. So the correct answer should be letter A, and that's it. Now, you could also, of course, do this by hand. You're just plugging in 0 for x. So 2 to the 0 is 1. Negative 8 times 1 is negative 8. Negative 8 plus 22 is 14. The only thing you have to be careful in this question, a lot of people will see 22 and think that's the answer because they're used to lines. Y equals mx plus b. B is the y-intercept. So when you see the number added or subtracted at the end, that's your y-intercept, and which is also true for polynomials as well. But that is not the case for exponentials, okay? So either you have to plug in 0 or go to the graph. Do not just assume, the number you see here at the end will be the y-intercept value. Next up, question number 18. So here, basically what's happening is you have x increasing by 1 and y is increasing by a factor of 4. All right? And you also know that this function goes through the point 0, 200. So a couple things. First of all, I can just look at this and I can tell that the answer is going to be D for several different reasons. First, if you go through and check each of these by plugging in 0, like if you do it for the first one, 0 to the 200 is 0, and this one's going to be 0. So this is going to be like 0, 0, which does not go through that point. So that's out. If you go through this one and plug in 0, you're going to get 0, 4. That's out. You could do this you could also do this in Desmos as well. And then the last, for C, you plug in 0. 0 to the 4th is 0. 200 times 0 is 0. Again, this goes through 0, 0. So that's out. And then lastly here, 4 to the 0 is 1. 200 times 1 is 200. So this one checks. Correct answer has to be letter D. Now, in addition to that, also notice it says for each increase in 1 in the value of x, the y increases by a factor of 4. So you can go through and you can look at these other possible answers, A, B, and C, and notice when you increase x by 1, the y is not going to increase by 4. Like you could just plug the values in a table, and I'll just show you an example real quick. I won't go through all of them, but like let's say you wanted to look at answer choice C, just hypothetically, right? So here's the graph of it. We go up here, click on the settings thing, we go to create table. So notice when I increase x by 1, 0 to 1, 1 to 2, blah, 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 is the y value increasing by a factor of 4? No. 0 times 4 is not 200. 200 times 4 is not 3200. So that doesn't meet that criteria. The whole thing about increasing by a factor of 4 is so it tells you this is an exponential function and it's got 4 right here as the number that's being raised, to the exponent. Next up, question number 19. So, honestly, the easiest way to do this, well, first I'll just say if you're familiar with trig functions and the unit circle and bow and all that stuff, right? You know that like here is 0 pi and then over here is 1 pi and then you go all the way, so like 180 degrees. And then you go all the way around again and you get over here to 2 pi and then you go around here and it's getting, going around below 3 pi and so on. So even numbers of pi are all going to be over here. So 2, 4, 6, 8, blah, 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 blah. That's all going to be over here, essentially equal to, 0 degrees. So the correct answer for this one's going to be A, because the sign of 0, and same as 2 pi, 4 pi, whatever, is 0. But if you're not familiar with that, you can just easily go to the Desmos calculator, type in sine 42 pi. Now, make sure, yep, I am in radians here. Click on little wrench, and it just gives the answer back as 0, and that's it. Literally just type it in 5 seconds, get the answer. If it wasn't 0, well then and it wasn't 1, say it was like a fraction, then you'd have to, just see, is it equal to 1/2, which is 0.5, or is it equal to root 2 over 2? You could just type that in and see if it's the same value. All right, next up, here we have one with a system of equations. And if this system has no solution, what is the value of h? So, a couple things here. With this one, you can actually do this one in Desmos because it is multiple choice. So I will show that first, and then I'll show how to do it by hand. I only recommend doing this using Desmos for problems like this when it is multiple choice and you have the answers in front of you. Because we can just add a slider for h, and we can say, okay, let's try -9. If it's no solution, we expect the lines to be parallel. Are these lines parallel? No. Are these lines parallel? No. Are these lines parallel? No. Looks like it's going to be D. Are these lines parallel? Yes, they look like it. Clearly don't see them intersecting anywhere. So yes, correct answer is going to be 18. Now, if this wasn't for multiple choice, then I would absolutely recommend doing it by hand, and here's how we would do it. So I take the top one, I put it into slope-intercept form, subtract the 5 over to the left, add the -9y over to the right, and get 18y, and then divide both things by 18. So we get y equals 4x over 18 minus 5 over 18. Now do the same thing for the second equation. Divide everything by h. Get y equals 4 over hx plus 2 over h. For there to be no solution, the slopes have to be the same. Therefore, 4 over 18 must equal 4 over h. Well, hopefully you see the same number on top has to be the same number on the bottom. Therefore, h has to equal 18. Just confirms letter D. Next up, question number 21. Okay, this one is actually a very easy one you can solve in Desmos. I will be demonstrating that first, then I'll show you just how you could use quadratic formula, which is going to be a lot more work. However, let's go to Desmos. Okay, so let's see if make sure I remember this correctly. We're going to use regression. And what we're going to do is not that. What I'm going to do now is I'm going to set x1 equal to the 1 plus root k. And what's going to happen, boom, there we go. We have our answer. It's letter B, 10. You can move on to the next problem. So what's happening here is I'm doing a regression statement. I'm saying x squared minus 2x minus 9. I'm regressing that to equal 0. And I'm also telling it that x1 is equal to 1 plus root k. So Desmos is basically being told what is the value of k such that when you do 1 plus root k and you take it and you plug it in to this equation and you force this equation to equal 0, like what is the value of k that makes it equal 0, that makes it true? Okay, so that's what's happening. That's how you solve these quadratic type of ones, and the correct answer is 10. Now, if you wanted to solve it using a quadratic formula, you could do that. You could also do completing the square. Completing the square is actually not going to be that much work on this one, but let's do quadratic formula. Okay, the opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. Okay, it becomes positive 2, becomes positive 2. Inside we get 4 plus 36. Okay, so we've got 2 plus or minus root 40 over 2. Notice this is not quite the same as the answer. We have to do more work because we need it to just be a 1 in front, not a 2. So what happens is you take square root of 40 and you simplify it. Basically 40 is, 4 and 10, and the square root of 4 is 2 and 2. So it becomes 2 plus or minus 2 root 10 all over 2. The 2's all cancel. 1 plus or minus root 10. This is my k value right here of 10. Okay, so if you wanted to do it by hand, that's how you could do it in quadratic formula. But again, it's so much quicker just to do in Desmos. All right, next up, this is actually a repeat question from, I think it's practice test 3. There are two different ways to solve this. I will show you both methods. First way is by hand. Uh, you might be tempted to think about getting a common denominator and like combining the fractions on the right and whatever, but no, it's actually much easier to bring everything over. So like subtract this whole term over to the left because it has the same denominator as the x squared. Put both those things on the top. Okay. Then we square both sides. So on the right side, we have 39 squared. On the left side, the root cancels out on the bottom, and you'd have just x squared minus c squared. On the top, you have x squared minus c squared, and I'm just going to write it twice. So now notice this and one of these parentheses cancel out. So you get x squared minus c squared equals 39 squared. X squared equals c squared plus 39 squared, moving it over to the other side. And then last, you can do a square root plus or minus c squared plus 39 squared. Okay, so the correct answer for this is going to be letter D. Again, this is how you could do it by hand. Now, let's take a look at Desmos. So what you're going to do is we are going to graph out the entire equation, and I'm going to do y equals left side and y equals right side. It takes me a little time, to type in the full thing. Okay, now I'm going to add a slider for C. Okay, there we go. Okay, so we're looking for where do these two things intersect. Okay, so we got one here, we got one here. So let's just export those. Export, okay, and we're only concerned with the x value. So I'm just going to delete this. So notice it's just plus and minus the same number, right? So now what we do is we go through and we check each answer choice and we see which answer choice equals one of those two numbers. So A, does that equal it? Nope. Okay, does B equal that? Nope. All right, let's go to C. 39 squared minus c squared. No, kind of close, but no, it's not the exact same number. That's what we're looking for. And then in D, okay, notice here I have the exact same number, negative 39.04625. It matches this basically intersection point, right here. So correct answer for this one is going to be letter D. Again, this is how you could use Desmos to solve the problem. All right, so I hope you enjoyed these solutions to Bluebook Digital SAT Practice Test number 10, the Math section, Module 1. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you have any questions or comments about any of these solutions, please do leave them in the comment section of the video below. If you haven't done so already, also check out the solutions to the same practice test 10, module 2A, the easier of the 2-second modules, and also module 2B, the harder of the 2-second modules. And lastly, if you want to learn more about how to use Desmos, for example, to do like the problem that I just did, please check out my ultimate Desmos guide to digital SAT math. Over 3.5 hours of tips and tricks and instruction and 45 practice problems as well.